Hello, everyone. How are you guys doing? As usual, those that want to join as panelists, just raise your hands and I will be adding you. All right, so we should get started. We're gonna start today. Our class is pretty interesting. We're gonna talk about collections, and we will be introducing a new control flow structure, which is it's also a loop, as we saw while loops in our previous class, but this class is going to be a for loop. All right, and it's important. I mean, we're gonna see how for loop in Python is different from other languages. We're gonna go through all of these slowly, but it's important for you guys to start wrapping your heads around like collections and for loops, because they are really important constructs in general in Python and in any other programming language, to be honest. So let's get started. I'm going to share my screen. There you go. And we're going to start talking first about collections. And maybe some of you have already read about collections or you already know something about them. It's important for us, at least for now, to focus on collections from a more abstract standpoint. All right, we should focus thinking about collections as what they are used for, not how, for example, they are implemented. So something that always happens that you guys might have read about, I don't know, linked lists or hash tables or data structures or 10 usual data structure questions in any interview, something like that, job interview. So those things are, of course, really important, but it's impossible to learn about those things without you understanding what collections are for. All right, so it's like you have to first use something before you can understand how it works underneath. And it's a clear example. Can you guys think about a car mechanic that doesn't know how to drive? The first thing that a car mechanic learned was to drive, and then that person then got into like how it works underneath. So it's the same thing here. We have to use this thing over and over and over and over, and then we're going to start understanding what's the difference between the different collections, what are the construct or the data structures used to implement them, etc. So collections are a super simple concept. They are just a container where we will be able to store many items, right, in the same container, and we will be able to reference that container that will, of course, contain many different elements. So the issue that we currently have now is that whenever we want to store, and here I need to big quotes, we want to store a value. In this case, we have a simple string. How do you guys do that, right? Like right now, what you do is something like, for example, user1 equals Ned, user2 equals, I don't know, Sean, right? This is the way you would keep track or references of different objects. If I ask you, can you please add a new user area, for example, you do something like create a new variable, right? This will be your third user. But you can't do these on runtime. Once the script is created, you can't add a new variable. You need a dynamic way of storing elements. So that's why we're going to use a collection. And a collection is a super simple concept. It's just a way for us to like wrap all these elements in just one construct, in one container, and reference to that container. So we're going to say all these elements, right? The most type, and again, here's like a super abstract explanation of these, and we will then go to like more detail about how they work, and we're of course going to do Python work with these aside from the abstract explanations. So what's the most common type of collection in general, and of course in Python, is probably a list. Those of you that have worked with other programming languages, you have also seen arrays, which are pretty similar to lists. And the way that a list works is exactly as it's shown here, right? So I'm going to start now with a more Pythonic way of these. The first thing that I have to say is that here it says that a list is the most common type of collection. So these means that there are many different types of collection, not just in Python. In programming in general, we have different types of collections, and each one of these collections will have a different trait, right? And we are not caring about that right now. We just want to learn again, in general terms, what collections are used for. I want you guys to start driving. Right now, you will be driving the most common type of how to put it, vehicle possible, which is a car. And then you will understand that there are different type of vehicles like motorcycles and trucks, and you will be able to differentiate them. And then of course we have different types of collections because they will have a better application in different use cases, right? So if you want to transport a lot of, I don't know, things, you will be using a truck. If you want to move fast and it's only you will be using a motorcycle. In this case, we will have different types of collections that will be better in certain use cases. But again, what we want to do now is just go with the most common type of collection, which is the list. This is how we create a list in Python. And here I will kind of introduce you to the concept of literal creation of elements. So what you guys have seen up to this point, for example, when we created strings, right, like name equals Ned, we are creating a string, and in this case, we're using what we call in programming a literal. There is a literal way of creating this thing. It's like I'm not putting, I could have done something like create string with N, with E, and with D, right? In this case, what I'm doing is I'm not using a literal way of creating it, right? I'm using some sort of artificial way to create the final object, which will, of course, be Ned, right? So this is a literal way to go back to strings. These are literal ways are you will create a string, just put in quotes and the string that you want, and literal because you can just read it. You know, it's like I can ask anybody to read this thing and that person's gonna understand that. You know, it's like, yeah, sure, you're putting name equals Ned, you know, anybody, even if that person doesn't know programming. In this case, we're using the literal way of creating a list. We're just creating a list, and by default, we're creating a list that has 1, 2, 3, 4 elements. As anything in Python, we'll be able to assign a variable to that. So I can do starx equals this list of elements, right? And of course, I will be able to then print these elements. So here, for example, we'll be able to do print starx, right? And I get this representation of this starx list. I can have many pointers to these house starx equals starx, right? And I'm still pointing right to the same list. House starx is pointing to starx, and starx here is pointing to this list. So they're just pointing to the same thing, but the actual list created is only one. This list is created by putting many elements, right? It's just constructed to contain many elements, but these elements, all of them, exist by themselves. So I could have done something like Ned equals Ed, and Sean equals Sean, and Sansa equals Sansa here, and A equals area. There you go. And I could have done something like Ned and Sean and Sansa and area. So I'm just creating a list, right? Again, a literal way of creating the list by passing the elements that I want to contain that list. How am I passing the elements? In this case, it doesn't matter if I'm just passing a reference to the actual element or if I'm passing the element by itself. In this case, it's exactly the same thing, like literally the same thing. I'm just passing around the element that I want to finally put. If I print this again, you will see it prints the same thing, even though I'm just pointing to the variables. Lists in Python are, and in general, they're a really common data structure. In Python, this is more important because lists are pretty powerful. Collections in Python are pretty powerful in general. Oh, by the way, I'm not recording this. Well, I think this live stream is going to take care of that. I'm going to start recording just in case. So again, collections in Python are really powerful, like really, really powerful. If you guys are coming from Java or C or other programming languages that are more strict, more static, you will find that collections in Python are a pleasure to work with. One of the things that I can do with collections, with lists in Python is put different types of elements. So I can put, for example, Sean, and I can put a 3. I can put a true value, and I can put a none, you know. So this means that a list is a heterogeneous data structure. I can put anything that I want. And I can even put other lists. So I can put here like children. They are Sean, Sansa, and Arya. And I can put here children. So this list, let's put here Ned. This list now contains different types of elements, so different that one of them is by itself a list. And I know this might be confusing now, so I don't want for you guys to feel confused. What I want you to know for now is that you can put whatever you want in a list. All right, that's the most important part. Now, let's move forward, and please, if you have any questions, just let me know. When we create a list, we're using the literal way of creating a list. We are passing each one of the elements, and we're separating these elements with a comma. And these square brackets are the ones denoting that we have a list, right? This is creating a list. I could, for example, just create an empty list. This is an empty list. This is the literal way of creating an empty list. There is the non-literal way of creating a list, that it's just, if I do list, and I just print that it's an empty list. This one is the one taking precedence. So there are different ways of creating an empty list. And again, it's just an empty container. It's like having a drawer without anything inside. It's just an empty container. Of course, you can then put things and etc. So let's see a few traits that we have, or a few capabilities we have with lists and collections in general. So again, collections might store, lists might store any type of element. We will be able to add, remove, and update elements, and this will not hold true for any type of collection. Generally, we're gonna now talk more about lists than any other type of collections, because some type of collections will not allow modifications like adding or removing elements. And they have many utility functions. So let's see, for example, and you guys can here follow the slides and to try it on your own, how to get the length of a list. So here I'm going to do this, right? And I'm printing the length of the list. Let me put one more element. There you go, now 5, right? So I'm getting the length of the list. This, the reason we're showing you this, not because we want you to like memorize every method or function that you can use with a list or a collection, but because it's important for you to start getting familiarized with these things, like slowly starting to catch up, to understand there are many things involved with lists and collections, and those things will make your life easier. We can add elements. So for example, I can append an element. It will just add the element at the end. So let me remove brand here so we have a smaller list. And I'm going to print the list after I have added raw. There you go. So now I can actually print it 2 times, before adding the element and after adding the element. There you go. So what we see here is that we have one list, and we're changing that list. Somehow it had 4 elements before, search had 4 elements, and now it has 5 elements. We're changing it, we're adding a new element to that list. We also have, for example, a way to insert an element at any random, we would say, it's not random, but any arbitrary position you want. For example, at the beginning, right? So we're gonna insert brand at the beginning or in position 2. We're going to learn more about positions, but now brand is here. Again, we're going to learn more about positions, because might not make a lot of sense right now. What I want to say is that you can just control where you want to put each one of the elements, right? At the end, at the beginning, in the middle, after this element, after that element, you will be able to control that. We will also be able to remove elements. There are 2 important methods. One of them is pop. So I'm gonna get an element here. I'm gonna get Sansa. I'm gonna get character. Character, I kind of blew up the question already, right? But if I do character starts.pop, it's gonna get me one of these elements, and it's going to remove it. pop assets as remove as says here, removes and returns by position, right? So here we're gonna get a character, and I'm gonna do two things. I'm going to first print the list, so you guys see that when we do pop, we remove one element. In this case was Sansa, and I will then print that element. So what you see is that it's not just removing it, but I can hold a reference to that, somehow, so I don't completely lose it. It's like I can say, please remove the last element, pop. By default, it's the last element, but also before completely dropping it, assign it here so I can then use it. Maybe I don't care about that. I just want to remove the last element, so I don't care about that. That's it. I have just updated my list, removing this last element. I can again pass a different type of a particular position. So in this case, remove and return the first element. So here we're returning either, returning and removing either, right? Ned, we're just killing him. Sorry. We're removing and returning either, right? So in character, we have now Ned in the first position, and this is then how the list looks like now. We have removed the first element. Finally, we have the remove method, that it's not returning anything, right? And it matches by the element. So instead of saying, in this case, what we're saying is remove the element at position 0. This is going to be the position 0, as you guys will see in a second. What we can do is say remove the position, the element shown, for example. And in this case, instead of saying remove the first, the last, the second to last element by position, we're giving the actual element that we want to remove. Remove shown, all right? And then we will, if we see the list, we see that shown is no longer there. Quick stop here. Again, there are many methods: remove, index, insert, append, pop. We don't want you guys to memorize them all. We will update the lessons with some practice for that. The truth is that there is no way to memorize all that. You have to use lists, you have to use collections in order for that to make sense, all right? So what we want you here is, again, start making these sort of conscious, like every time you're working with this, you should be aware and mindful about what are the methods you're using. And usually there are useful methods. Sometimes we find ourselves like, how can I remove the element if I don't know the remove method? The only method that I know is the pop method with the position, right? And I want to remove the element shown. What I would be doing first is searching for the position of shown, then I could get the position and they could be able finally to remove it. That's because I don't know about the remove method. So knowing more methods, will give you more tools to make your programs shorter, more concise, and will save you some trouble. Any questions about these? Adding, removing, length. There are many more methods. I don't know if many more, but there are more important methods and operators. We are not seeing operators for now, but we're going to see them later. All right, this deals with modifying somehow the list, right? We're adding or we're removing. There is also a way to read the list, right? This is a create/delete operation. We're removing or adding elements. There is also a way to access it for reading, like getting a particular element. Give me this given element, the element in position 0, the element at the last element, the second to last, again, giving the position. You can also get all of them, read all the elements. There will be different ways of reading and accessing these elements. To do so, we're gonna start now. We're gonna see in more detail the positions of these elements. This is the way to get a particular element. So I'm gonna print starts at 0, and this is the way we read it. We say starts, right? The list we're accessing at. This is the way I read it list. Like at this is the operation at the index operation. give me the element at position 0 from this list, and I get net, right? Now, how are these positions? You guys see a few like negative indexes here. It's pretty simple, and it just follows kind of this logic. A list, and you will find this also similar to a string, is a zero indexed collection. In Python, everything is zero indexed, or all the indexes will start with the number 0. So the first element is the number 0, the second one is the 1, the third one is the second, right? So we will be having something like, if I put a comment here, this is the element 0, this is the element 1, this is the element 2, and this is the element 3. There you go. So for example, the element, the third element, will be the element at position, we say third in our minds, right? Like third element. The position will be 3 minus 1, the second one, because we're starting with the index 0. So we get here, right, area, which is, of course, first, second, third element. It's actually position 2. What happens if we want to access, for example, the last element? We're going to say, give me the last element. In this case, the fourth element, 0, 1, 2, 3, but position 3. But it's first, second, third, fourth elements. If we get the position, the length of this list, again, let me get you the length again, length of this list. You're going to see that this list has 4 elements. So that could be kind of the fourth. We have 4 elements. Want to access the last one, it's the fourth one. But we actually say when we want to get the third one, we will get 3 minus 1. So we will do here, if this is the fourth element, let me go up to the end here, fourth element, we will actually get, right, from starts 4 minus 1. But we also know that this is kind of a dynamic position. I could get these computing it. So last position could be the length of the starts list minus 1. So here I'm going to get last position, right? So this, if I have, let's show it how it works. If I have a new element here, brand, it's going to give me always the last element. Even, for example, if I add it later, right? So I'm going to do, let's print it here, and then we're gonna starts.append brand, and we're gonna do the same thing again to get the last element. There you go, Sansa now brand, right? So it's always the last element. This is a pretty common operation, getting the last element or the second to last element. How could we get the second to last element here? It would be, we want to get the one here, so it's going to be this one minus 1 minus 2, right? So here we're going to get area, and here we should get Sansa. There you go. So these, again, are really common operations. So Python has kind of a built-in way of access those last elements by simple position, and that's with a negative index, right? So each one of these elements will be accessible both by a positive index, like, right, let's actually see an example here to make that a little bit more clear. So again, this is going to be the position. Let me copy this here, and it's going to be -1 here. So we can get Sansa either by doing starts at 3 or starts at -1. It's the same thing. There you go. Gets us the same element. The important part here is that this is going to be kind of dynamic. We will always get the last element with these -1. With the 3, we're not so sure, because if this is this list has now a new element, we're not getting the last element, because the last element is actually 4, which again was length of the starts -1. So -1 is kind of dynamic. It doesn't matter how many elements you have in the list, it's always the last one, right? The same way that 0 is always the first one, -1 is always the last one. And again, we can also get like -2. This actually, here we have this -2. You know, this one is going to be -3. So we can get position 3 or -2. There you go, gets us the same element. So it starts here, 0, and then starts counting up, incrementing, like 0, 1, 2, 3, 4, or starts at the end, -1, and start decrementing, -2, -3, -4, -5, until the end of the list. Any questions? You guys are following it? It's pretty simple. Again, important part here is maybe separate like the reading operations from the creating/updating operations, like adding elements, removing elements, etc. Now, there is something that we can do also here with lists that are more like native operators. And by native operators, I mean that we will be able to do a native operator. Means something like 3 + 3. You know, this is like a more native. It's not a good way to express it, but I just want you to get it in that way. In this case, I'm just like adding to numbers. Well, we're gonna have some sort of these operators also for lists. So we will be able to, for example, we say new Starks. We have like a Bran and a Rob. We will be able to do Starks plus equals new Starks, and we can print now Starks. You guys will see we have 1, 2, 3, 4, the 4 original elements plus the last 2. So we're adding both lists together. We can also use the plus operator, but it's a little bit tricky. The idea of the plus operator is that you will get it. Like, it's like, if you guys do these, let me stop for 1 second. Let me separate these, right? Just comment it out for a second. If you have like x = 3, and then you do y = x + 2, for example, and then you print x, what should you see? You're gonna see 3. X is never changing. The same thing, again, this is not changing. We are just getting whatever we have here and we're adding to. With lists, it's going to happen the same thing. We are gonna do final list is going to be Starks plus new Starks. So we will be getting final list, right? Final list is going to be this big one, but these hasn't changed. I'm gonna show it to you. Starks. Let me here put a message. Starks. There you go. So Starks is not being changed. It's not as new Starks is also, it isn't changed either, right? So no list is going to be changed. We will just create a new one. So in this case, 2 is not changing, 3 is not changing. We're just getting a new number, which is 5. But x is the same. So let's put here z. We have y = 2. So here we're do x plus y, and we print y and z, right? There you go. So let me comment this thing out once again. There you go. So x remains the same, y remains the same. We're not changing this one. We just have a new number, z, that it's the result of adding these with these. The same thing happens with, there you go, with lists. So we're having a new one. Now, we also have this, again, is sort of creation/modification type of operator. We also have one important operator that I'm just going to mention really quickly, and then we're going to move to something different, which is the in operator. So I could, for example, it's like a question. It's also for reading. It will not modify the list, but it's for making the question, asking, is Edward in Starks? And please note that this kind of read, let's put Sean here so it's shorter. This reads well, you know, it's like it reads like English. Is Sean in Starks? It's gonna give you true, of course. Or is Rob in Starks? It's gonna give you false, of course, because Rob is not part of this list. All right, so this is also an important operator. Any questions? So to kind of wrap it up, this part, lists have many utility methods that and operators that are going to make our lives much easier. So again, while you guys are working with these, try to read the documentation. You know, the Python documentation is pretty good, has all the different things we should be aware of regarding methods, operations, etc. So as you guys are making progress, like just keep reading documentation. You know, you Google something, how do I do these? You will get many different results or options to solve that. Try to read each one of them and slowly start to put all these tools in your toolbox. You know, like you might be looking how to append a new element, but in between you read about the plus operator for two lists. So don't just keep that, you know, like read about that, understand how it works, and that will sit in your brain, and then you will start like picking it up whenever you need it. All right, so there is one more thing we can do here. So we say we can store any type of elements. It was a heterogeneous collection. We can add, remove, update elements. We have many utility functions and operators, right? We can get the length of a list. We can check if an element is present in a list. We can do many things. And finally, we can iterate through the elements of a list. And this is a really important thing. So we can kind of read each one of the elements in this list. So what I'm going to do now, right now, is I'm going to just show you how I iterate over all the elements in the list. And then we're going to see in more detail how this works. We iterate with the for loop. And the for loop takes this general form. For element in here, we're going to put our collection. And here we're going to do something with our LM. And LM will loop through each one of these elements. All right, it's important because those of you that have done something like for I in, or no, sorry, like var I, you know, I equals, no, I equals 0. I don't remember the syntax, I plus, you know. This is no how for loops work in Python. In Python, for loops are what other languages could call a for each or for in. And the idea is it's going to loop us through each one of these elements. So what I'm going to do, super simple, is just loop over each one of the elements in the stars collection and just print it. And I'm going to give a better name here, character. There you go. So I'm going to do for character in stars. There you go. And I'm just printing each one of the characters in this collection. So let's see in a little bit more detail how the for loop works. We have a super simple example here. We have a shopping list, and this is the final result. We're showing you the final result. This is what's going to look like at the end. And then we're going to start like going over these step by step. All right, but for now, just showing it, like I get this thing, copy it and paste it here and run it. We're going to see eggs, milk, and bread. It's the same thing we have here. Now, let's go over these step by step. First step is, oh my God, sorry. First step is we just initialize a shopping list, right? We have a list initialized. The second thing that happens is that we're going to start iterating over it. And this is the important part. We do for item in shopping list. And here we're matching by element. So item, as you guys see here, is equals to eggs. Items is not 0. It's not a number. It's not I in general, in plus something. It's the actual element. Item is the element X. What we're going to do now is get into the body, right? So each for loop, as you guys saw, for example, with the if statement right here, if was if condition body, right? While loop was while, condition, body, right? All these were the same in the same way. A for loop, of course, also has a body, and you guys can do whatever you want here. We are just printing just one line, but you can have as many lines as you want, and you can do pretty much whatever you want. You can say, like, store your elements in a database, send an email, like each one of these is a user's email, so you can send an email to each one of them. You can do whatever you want in this body. So once we get the element, it was one step previous, we were getting the element, we then execute the body, this body is printing that item, so we get in the output X. The for loop realizes that there are still elements to go over. It just has gone over these elements. So it's going to now get to the second one. So it restarts again. Remember the while loop, that while this condition was true, it would keep iterating and iterating and iterating and always reach the bottom and go back again to the beginning. And while the condition was true, it was looping. The same thing happens with the for loop, as long as there are more items to read. You know, as in the condition for loop is that there are more items to read. So in this case, it has X, print X, goes back to the top and says, are there more elements to iterate over? And if the answer is yes, it will just keep iterating over. So it gets the second item, which is milk, right? So now item has completely changed its value. Now item is equals to milk. It was previously, it was equals to X, now it's equals to milk. We then execute the body, pretty standard, the same body as before, we just print it. And we'll go back again to the beginning, and the for loop asks the same question again. Are there more elements to iterate over? The answer is yes, so it gets the next one, bread. Now again, item is equals to bread. We are stepping over the, like, item, the variable item, the name item is holding each one of the elements at a time. So we are like stepping over the previous item one. That's why we have like these crossed item values. We then execute the body once again, print the element, we get bread, and the for loop kind of just realizes that there are no more elements to iterate over and just stops and moves out. Make sense? Questions? No? Yep, I have one. I had a question about how to combine two lists, but actually modifying the list. Yes, is that a thing? Yes. So you have two different options. You can, for example, you have two lists, you said, right? We have second list. It's gonna be like 9, 11, 2. And here we can, if you want to modify, what do you want to do, James? Modify this list, modify this list. Which one would you like to keep it on? So if you want to modify this list, what you can do is, for example, do shopping list plus equals second list. And that could change these lists, and I could add these elements to the list. So now we're going to print shopping list, and you will see that it has all the elements. It has the 3 original ones plus adding these 3. What we can also do now using a for loop is manually add each one of the elements. So it would be something like, we would iterate over this list. We would do, we're gonna do something like, we can iterate over the second list, like getting this element and appending it to the original list, getting this element and appending it to the list, getting each element and appending it to the end. We can do that pretty simple, just doing something like for number in second list, shopping list dot append number. And finally, I'm going to print again shopping list. There you go, same result as before. So what we're doing here is again going over each one of the elements here. We're getting the number 9, and then we're doing shopping list dot append number 9, adding it at the end. Number 11 and appending it at the end. Number 2 and appending it at the end. So yep, different ways. So Taylor, sorry. What or how does a for statement read out in regular English? Like how you did with print raw? What do you mean, Tyler? It's like it reads. So if you're looking like for an analogy, I think it's this. Let me clear the screen here. I think it's just getting used to these notation, like for item in shopping list. It's like saying like iterate through this item, iterate through or over each item in this collection and get it to me somehow so I can use it. It's as simple as that. So let me give you an example. Let's say we have 2 examples. We're going to do 2 examples. We're kind of really early where we have already covered all the topics for the class. I'm going to show you 2 examples. The first one is we have a list with numbers 3, 1, 6, 9, 2, and we want to sum all these elements in this collection. So what we're going to do is we will do for number in numbers. I'm going to put a pass here. Again, this is a body, so if I don't know what to put here, I can just put an empty body with pass. What I'm going to get here is the number. I'm going to get 3 or 1 or 6 or 9 or 2. So I kind of have to keep track of the previous ones. Like I'm going to get the number 3, and the number 3 will be available here. And once I have already passed that loop, we're going to go and get the number 1, and we have already lost the number 3. So I have to keep track of that. The simple way to do that is, of course, doing like result equals 0, and then doing for number in numbers, result plus or actually we can do equals result plus number. And finally, print the result of this. So here I get that this sum, this entire addition operation with all these operators are operands, is 21. We're adding each one of these elements. Again, this is a body, so I can do whatever I want here. Let's say that I want to sum only the even numbers. So what I can do is if number modulus 2 is equals to 0, which again, this was pretty much of saying this is even, this number is even, add the number, but only if this is the condition. Which are the 2 even numbers, 6 and 2, so the final sum should be 8. So again, this is just a body. I am working with that body in whatever way I want, and I'm working with this current element in whatever way I want. So let's say we want to, we have a list of, let me see if we have here something we can use. We can, so we have names. We're going to change names here, Bob and Sean and Betty and Mary. There you go. We want to get a list with all the names that start with the letter B, right? Like Bob and Betty. So what we can do is we can start, again, we're going to do something like for user in, let me change this name, users, for example. For user in users, this is a pretty common pattern, by the way. It's for singular thing, plural thing, collection. The collections are usually expressed in a plural way, like users starts, things. And of course, when we iterate over that, we're iterating over each one of these elements. So I think this is related to like Tyler's question, like how do we read it naturally? So for user and users, we will do, what we can do is just get users starting with B, I said. And what's gonna be user starting with B? It will be, the final result will be just Bob and Betty. This is what we want. And this is, of course, a list. Of course, we're in this case, we're hard coding it. We don't want that. We want to do it dynamically. So I'm going to start with an empty list. And I will iterate over each one of these elements. And as I'm finding them, I will put in the list. So I will start with the first element, Bob. I will check, does it start with a B? Yes, so add it. Then I'm going to go to Sean. Does Sean start with a B? No. So don't do anything. Third element, does Betty start with a B? Yes, so add it too, add her too. Finally, Mary starts with an M, so I don't add her to the list. So express that in Python is going to be super simple. I just do like if user dot starts with B, user starting with B dot append the user. And finally, I'm going to print this list to see the result. There you go, we have Bob and Betty. I'm going to put here Bruce. There you go, we have one more element. So again, we will be iterating over each one of the elements. I know that most of you, not most of you, but many of you will be tempted to do something like, well, there you go. Something like, because I know that some of you might already know about this, like for I in range of users, user equals users at I, print the user. If you don't know what I'm talking about, that's fine. Forget about what I'm saying. You didn't see anything. So just look at other side for 5 minutes. If you do know what I'm talking about and you know the range function, I'm gonna ask you, please don't do this. This is the #1 noob mistake in Python. It's like people coming from other programming languages, JavaScript, Java, they try to force Python tools into their previous mindsets, right? So in this case, this is what they are used to, like iterating over an element, a number, a position, and getting the actual element at that position. While in Python, it's much more simple. You just iterate over the element by itself. You don't need to do all this thing of getting the position and then getting the element at that position. You just iterate over the element at the position. These might not click right now. You guys might forget this. What I want you to think is that whenever you guys are working with a for loop, stop for a second and say, do I have a range here and an I, X, position, whatever variable? If that's the case, please double check that you're not doing this, all right? Because this is a really common mistake, but seriously, really common mistake. So just information for you in that respect. Questions? Oh, you guys are doing fine. All right, so I think this is a record time for this class. I thought it was going to be much more convoluted. To be honest, this is the most important topic that we have seen up to this class and is the one that has taken us the less time. All right, we have introduced lists. We will start working with, we will add all the assignments to work with lists and collections in general to the Learn platform. Yeah, Chad, yeah, something like that. Yes, completely. Using an I with position. I don't say that using the traditional for loop is Pythonic. It's just the regular way. It's like there is no other way. Using the I variable is just it's smelly, as you say. We will add all the assignments for lists. If it does, it will take us some time. But if you guys go to a Learn platform and search for the introduction, you will have a few assignments to start working with, at least for now. So let me point to you them. Collections here. Define a simple list. These elements, these assignments are all something you guys can work with. So I will put them in the message in the chat Slack channel later. All right, if you guys don't have any more questions, I think we're done. It's record time again. We usually take a lot of time in at least in the intro course with collections on for loop. It takes a lot of time. Yes, Andrew, I will notify you guys when everything is new. Again, you can start with these. I'm just gonna send them right now over Slack. There you go. Audience, the Adrian's question. At least for now, it's something to start with. All right, it's fine. So just start with that, and we will update you as soon as we upload them. All right, again, happy to have you once again. I don't think why we have so few people, but you are the ones staying strong, right? So congratulations. We're making a lot of progress. So again, congratulations to you. So you all have a great weekend. Have a great Friday. All right. And see you next Friday.